Hello SCADA enthusiasts, this is Jordan with my final project. I'm going to start off with the basic layout of my factory here. It's pretty simple. I've got a base machine and a lids machine station. Um, Both of them are set up in relatively the same way. At each end there's a conveyor that feeds raw material into each one of the stations. It feeds in down the line, reaches these stop blades. Once both these stop blade sensors are met, it will feed into the assembler where the lids are conjoined to the bases and then off into non-existence. Here is my basic or my main operations panel here. The top one here is for starting or stopping all of the operations. Then down here for my base machine, my lids machine, and then the assembler. Right here is for letting me know if everything is ready, if it's stopped, or if there is an alarm present. Here is my IO map. This is where I did a lot of my alarming, as well as my start-stop function and my heartbeat. Up top first here, of course, my heartbeat. Anytime that my heartbeat is not being read within a 5-second time parameter, it will trigger an alarm. I have this pseudo bit here to kind of make a pseudo communication failure. And down here, this is for my start stop of my main operations buttons. Anytime the operation is not ready, the main light is on. If not, the red light. This no reset here, this is for when I was programming and I didn't feel like starting over or starting FactoryIO over again and reconnecting and re-downloading my program. So I just set up all of these resets. This is my reset operation for if we have an alarm present. And then I can reset it here using this unlatch bit, and also resetting some of the timers and the counters that I have set up. These timers here are specifically meant for alarming. These counters are kind of for redundancy. And here is my actual alarming, where if base machine or lids machine has an error, or there's a comm failure, or any of the full alarms are tripped, it will latch in the reset bit. And if the reset bit is latched in, we got the main reset light will turn on. And if there's a comm error or any of the machines have errors, this yellow stack light will flash. If any of the conveyors are full, it'll stay on solid. Down here is actually kind of a stopping protocol, I suppose, where if all of the base conveyor sensors are met, it'll stop the machine for a certain amount of time, which is 30 seconds here, and then it will restart it after that 30 seconds. That's kind of my catch-up protocol there, allowing the lids machine to catch up with the bases machine if all the conveyors are full. If the conveyors are full on the base side and the lids conveyor has nothing going into it, then an alarm will trip, and that will be my base conveyor full alarm, and vice versa for the lids machine. And that's actually this is the alarming for the base conveyor and the lids conveyor full alarms, where if all these sensors are met and all the other sensors are not met while operation is running, it will trigger the alarm, and again vice versa for the lids. And this is the same basic stop protocol as with the base machine. It's got a 30-second time delay in case the base machine needs time to catch up. And down here is my basic start-stop operation for the base machine. If the base machine is ready, base light will be on. If not, the stop light will be on. And if the base machine is ready and there are no alarms present, it'll jump to the base main logic. And this is also basically the same logic as with the other start operations. Then once the lids machine is ready and there are no alarms, it'll also jump to its main routine. And the same goes for the assembler. Start, stop, if it's ready, light's green, if it's not, light's red, and then it'll jump to the assembler. And this is my main logic for my base machines. Base machine is ready and operations are ready, machine will start. If everything is ready and there's nothing met at the main or the base material conveyor, the conveyor will start until that sensor is met. How I have these next rungs set up is the base exit machine conveyor that's able to hold 2 products at a time, and it'll actually move one product from the exit conveyor onto the enter assembler conveyor, where at the enter assembler conveyor it'll wait until both the stop light sensors are met, and then it'll flow into the actual assembly line. And here are a lot of my counters. Originally I had them set up to turn on and off the conveyors. Now I'm using them as redundancy in case I have issues with FactoryIO turning things on when they shouldn't be, or keeping them on, or turning them off when they shouldn't have been turned off. And it's basically the same logic here with the lids machine. Again, the lids exit conveyor can hold up to 2. Once it holds 2, it'll stop running. The lids enter conveyor will only hold 1, and it'll actually, both the lids enter conveyor and the bases enter conveyor will start back up again if both the stop light sensors are met and a timer is triggered, which that timer is this assembler timer 1. And again, I have my counters down here, again originally used for turning on and off conveyors and such, and now it's primarily just used for some redundancy. So here I have my main logic for my assembler. If both of the stop light sensors are met, it'll trigger a timer here, which when the timer is enabled, it'll start those enter assembly conveyors back on. When it is not enabled, these stop blades will actually go down and let the product go onto the main assembly line. And down a little bit further here, this rung will begin another timer if both these conditions are met. Base counter 5 is done and the clamp sensor is met, and that will actually initiate the clamping phase of the positioners. But the clamping can only be done after they've met the sensor and after a certain amount of time has been met, in this case half a second. It's giving the product enough time to go down the conveyor, or actually meet the sensor and go down the conveyor enough to be clamped, where it's held in position and then later assembled. This bit of rung here actually restarts the base assembler conveyor. This is actually where the finished product is, and these bits here will start the conveyor back up again and move the product down the line and removed. This logic here is for the lids. After the lid clamp sensor is met, it'll also give the lids enough time to reach the actual clamp to be clamped. And further down here, we have the actual assembly of the product, where when both of these positioners are clamped, another timer will get triggered, and it'll initiate the second phase, where the assembler will position itself over the lids, and it will, well, it's actually already positioned there, and it'll go down to 10 until the assembler detects the item. And once the item is detected, this timer will initiate, and once the item is detected, it'll start the grabbing phase. And this timer here will actually initiate this rung here, as well as the done bit, or the grab bit, which will then move the assembler up just enough to make enough clearance to get over into the next conveyor line. And then this timer here is initiated, which will move the assembler over into the next conveyor to position itself over the bases, where this next timer initiates, and then it will move the product down onto the actual base. And this timer 8 here will actually disengage the grabbing phase, so it'll let go of the product so it doesn't bring it back up and throw it all over the place. And these two timers here will initiate the actual homing of the assembler. When this timer 9 is done, it will move the assembler back up into its vertical home position. When timer 10 is done, it'll move the arm back horizontally into its home position, completing the homing phase. When the timer 10 is done, it'll start the timer 11, where the timer 11 will actually initiate some of the finishing phases, where it will raise the base positioner up, and then this will actually turn on the base's assembler conveyor with the finishing timer enable bit here, which will give it enough time to move the product out of the assembly line and into nothingness. This finishing timer is pretty much here for the sake of redundancy. It makes sure that these things are counting down properly. Sometimes the product wouldn't get conjoined properly, and the sensor would actually count too. So I put the timer there to count down the counters correctly, as well as to count up on the other timer, or on the other count up. When everything is finished, it'll actually reset all of the timers, as well as the first finishing timer. With that, we can move on to the actual process of this whole factory. To get started, of course, we gotta start all the operations. You can start in any sort of way. I like to just get the machine started first, and then to start the actual operation itself, which will begin all of the phases. We got the material getting fed into the machines on both ends, which then gets machined into the actual CNC. Right now I'm going to show a COM failure, what that kind of looks like. And so once the COM failure has been initiated, everything stops. We got the base machine and this machine stopped. And as you can see, there's yellow over each one of the machining stations indicating that they're stopped. And then we've got the light here which indicates that there is a I suppose a major fault. In order to clear that out, we have to stop all of the operations. And then we have to reset all operations. And that'll start everything back up from the beginning. Now everything is back to the way it should be. And so that now the lids are making their way to the stop blade sensors. And these are the clamp sensors. As you can see, they waited just a little bit before they actually clamped. And then they're actually getting assembled here. And this will raise, this conveyor turns back on, and then everything gets reset with that finishing timer. Next, I will show a conveyor full alarm, which that'll actually take a bit considering how slow these take. So I will pause it and let one of these conveyors get filled up all the way. Now that one of the conveyors is almost full, it'll actually go into a stop phase where when these are full, this machine will actually stop because we don't want this thing to get overloaded for no reason. So now that this conveyor is full all the way, I have another alarm present here. That's what this yellow indicates. It's not a major fault, that's why it's solid. So again, all we gotta do, shut everything off. Then we gotta reset it. And start over with this operation again. And there we go. And since all these are still full, this machine isn't going to be doing anything. At least until this gets moved down here and there's enough room for some extra bases. I'll wait here a bit. And things are back the way they should be. And given that this is still stopped, it's actually got that 30 seconds it's got to wait yet, letting the lids conveyor or the lids machine catch up a little bit. So now that I've kind of demonstrated what it can do and some of the PLC alarms that it has, I can now show you the HMI and all the fun alarms that are set in that. So I have security set up in it where I am the administrator. I can do anything I want. I have two others, an operator and a guest. The operator can do anything that they want other than changing users and setting different alarms. So here are actually some of my alarms now. Operations aren't ready. None of the assemblers are ready. All the conveyors are off. And those are all active right now because there's nothing that is on. Go down a little bit further. There's some of the old errors, communication and all that. And it'll actually tell you if a reset is required. So here is the factory overview of, well, of the factory. Here I got my start and my stop, my reset, and here's for the bases and the lids and the assembler station as well. So just like with the main panel, I like to start off with just starting all of the lids and base machines first. So now all of those things are ready. We can start the final operation. And there we go. So all of these indicate that, these ones indicate that the conveyors are on and that the base and lids machine are ready, as well as the assembler here. The circle here is my heartbeat. If that goes away for too long, another alarm will trigger. So I will do that pseudo alarm trigger again, and we will see that alarm event in the HMI. Give it 5 seconds and stop. Machines have stopped. Though the conveyor should be off. That's just some weird FactoryIO thing. It just doesn't want to do anything. So as you can see, my heartbeat is gone. And so again, we gotta shut all of these machines off. And I actually use toggle buttons for these. So you actually gotta turn the start back off. And so with all the machines off, we can now reset it. Whoops, I'd have to turn that off. Yeah, so now we just reset it. And now we can go back in and turn everything back on. Base is on. And now we will start the operations over again. Well, we can't because the alarm is still present. So the alarm was still present because I forgot to turn my pseudo failure bit back on. So anyways, the HMI toggled the reset. You can see everything is off. The reset button's not on. Red light is on. Everything's off. Yellow light's off, so there is no alarm. Now we can go back, start up everything. Just look at that. Bases, the lids, now the overall factory. Everything starts back up from where it left off. Now we can go check out that alarm that used to be there. There it is, 807 communication error. And then here are the other alarms for system set required, communication failure, and the assembler conveyor is off because that's kind of what we wanted. And so that pretty much does it for the actual project. Or suppose I forgot to mention that I do have the security set up, like I said before, with the guest operator and such. So we will log into the guest account. And so the guest can look at everything, but they won't be able to access things like the alarms or the push buttons. So you can see all of the push buttons to start, stop, and reset are disabled, and you can't get to the actual alarms screen at all. That is given to the administrator, but you can log out or log back into a different user. I'll do operator. Well, the operator can pretty much do a whole lot of the same stuff the administrator can. And that's pretty much what I got for you. Some of the things that I would have liked to have done a little bit differently with this is probably make a prettier looking HMI, maybe some better alarming. But I would have also liked to have set up maybe some additional machining stations, considering these are super slow and just kind of a real drag watching it. But also a sorting station to separate the different color material that goes into each one of these stations here, as well as a palletizer to put everything in boxes and to put it on pallets, and of course to move that to their own separate sorting station, of course, and probably some more alarming as well. I couldn't exactly think of too much other than full conveyors and the pseudo COM error. So that pretty much does it for this actual presentation. I hope you liked at least some of it. I know it was fun. Anyways, thank you for your time. Appreciate it, as always.